Here we have a question about magnetism. So here we've got the magnetic field around a single straight piece of wire. And what do those arrows represent? Well, it says it's magnetic field lines. So the arrows represent the direction of the magnetic field. It says they're magnetic field lines, and arrows tend to represent direction. Complete the sentence. As the distance from the copper wire increases, the magnetic field, well, it decreases. As you get further away from a magnet, you feel a weaker magnetic force. Just like when you hold two magnets close together, they attract, but if you hold them at different sides of the room, they're not going to do anything. And suggest how the field lines in figure 1 show the variation. So these are your field lines got very close to begin with, and then getting further apart as we go out. So the distance between the field lines that's what's changing in the diagram. And then you see there's a smaller distance when it's stronger. So this is applying your knowledge that magnets are stronger close by and applying that to this particular diagram. So these are the field lines. If they're close, that's where it's strong. As they're far apart, that's where it's weaker. We have a lovely graph question here. You'll need a ruler. Obviously you should do it in a pencil. That way, if you make a mistake, you can rub it out. Determining the increase from 12 to 18. So again, we've got now use our graph. So go to 12, go across, go to 18, go up and across. We got 1.4 is 0.5, 0.6, 0.7, 0.8. So difference 1.4 minus 0.8 give you 0.6 arbitrary units. So when you are doing this, be very careful with your lines. Obviously you want to look straight down, which is something I can't do at the moment. Okay, next question of multiple choice. How could the strength of magnetic fields be increased? Well, there's 3 C's to increase current. There's coils, current, and core. By increasing the coils or the current, or adding an iron core, you make an electromagnet stronger. Okay. We can also do the same with potential difference. We tend to combat the current, but the potential difference could be increased as well. Obviously, increasing temperature is not going to do anything. If you spread the wires apart, you're making less coils. And if you put a high resistance wire, you're going to decrease the current. Here we have a coil of wire. It wants to draw the field lines. Now you need to remember an electromagnet has the same field lines as a bar magnet. So out of the north, into the south, and wrapping themselves around. Make sure you always have arrows going from north to south. Without the arrows you'll lose a mark. And how can the solenoid be made into an electromagnet? Well, taking this old electromagnet to make it stronger, you could add an iron core. So that will greatly increase the strength.